I did a 7-year experiment where I lived with cholesterol levels higher than most doctors see in their entire careers. But when I underwent advanced heart imaging, there was no plaque whatsoever in my heart. My heart was astonishingly pristine, and I should have anticipated what happened after that. Everyone started asking for my secret. How do you build a heart that appears resistant from heart attack, from atherosclerosis? So in this video, I'm gonna walk through some of the highest yield strategies when it comes to protecting cardiovascular health. We're gonna explore sides of cardiovascular biology you definitely don't learn in medical school. Information drawn from thousands of hours of study, dozens and hundreds of papers. But to respect your time, I'm gonna do my best to boil down the highest yield, most practical information into 20 minutes. Let's go. I have with me a little toolbox. Inside, there are 5 tools for heart health. Actually, reverse plaque progression, 22% reduction, and a 36% reduction. Why does this matter? A predictor of death and cardiovascular risk. Something most doctors don't know. And are you ready for this? Now, real quick before we begin, if you want deeper dives on anything we discuss in this video, or if you want to go broader and deeper with me on heart health, metabolism, gut health, brain health, longevity science, check out our newsletter, Stay Curious Metabolism. There's a reason it's reached #2 overall best-selling in science globally on Substack in just 1 year. Members call it one of the best investments they've ever made in their health, and honestly, it's one of the best ways you can support the work we do here. Now, with that plug out of the way, we're gonna set this one up a little bit differently. Rather than just rattling off supplements and lifestyle actions, I have with me a little toolbox. I want to frame this as a practical toolkit for cardiovascular health, so I want to make it visual. We're going to go through this toolbox. Inside, there are 5 tools for heart health, each represented by a different object in this mystery bag, which brings us to tool number 1, represented by a scoop. This is nattokinase. And apparently, yes, there's an ice cream scoop in my toolbox. Don't judge. I use this ice cream scoop to represent nattokinase because it's one of the few compounds suggested to actually reverse plaque progression, or, being cute, scoop out plaque from arteries. For example, in one large human study involving over 1,000 participants, individuals taking high-dose nattokinase for 1 year showed something striking: regression of atherosclerosis, heart disease. Using ultrasound imaging of the carotid arteries going from the heart to the brain, researchers observed a 22% reduction in carotid intima media thickness and a 36% reduction in coronary plaque surface area. Even if it's not a perfect study, and no studies are perfect, this is a finding not to be overlooked. Sorry, I had to do that. But what even is nattokinase? It's an enzyme derived from a traditional Japanese fermented soybean dish you might have heard of, natto. It's been consumed for over 1,000 years, and that dish, natto itself, is actually linked to lower rates of cardiovascular mortality, on the order of 25% lower rates compared to those who consume basically no natto. But how nattokinase, the enzyme, works to protect the heart is where things get really interesting. There are 3 main effects. First, anti-clotting activity. Effectively, nattokinase makes the blood less sticky and less prone to build up clots and debris in arteries. Second, blood pressure reduction. This has been shown in human randomized controlled trials. Nattokinase reduces blood pressure, which is a risk factor for heart disease. And funny enough, it acts by inhibiting an enzyme called angiotensin converting enzyme, ACE. You don't need to know what that is. The point is, this is a similar mechanism of action to many popular prescription blood pressure medication called ACE inhibitors. These end in the suffix pril, like lisinopril. I probably could go into my parents' medicine cabinet now and find lisinopril. But by reducing ACE activity, nattokinase allows your arteries to relax, lowering blood pressure and improving cardiovascular risk in the process. And finally, third, nattokinase can reduce oxidative stress. Oxidative stress plays a central role in vascular damage, inflammation, and heart disease. But nattokinase helps by increasing antioxidant defenses, protecting against blood vessels. I kind of imagine it like you have these little free radicals bouncing around, and nattokinase is like the Pac-Man that gobbles them up. So really, nattokinase is kind of like a Swiss Army knife, more complex than a scoop. Nevertheless, This convergence of effects, the anti-blood clotting, the lowering blood pressure, the protecting against oxidative stress, is what allows nattokinase to scoop plaque out of your arteries. That said, to get the best effects, you probably need higher doses on the order of 10,000 fibrinolytic units or more. Just keep that in mind. Now, let's explore our next tool. It is an ice pack. Ooh, that's cold. I use this ice pack to represent something called TUDCA. First of all, yes, there's some weird things in my toolbox, and no, I probably shouldn't be keeping an ice pack in there, but I'm weird, you know that, that's besides the point. The reason I choose this ice pack is because this is getting really cold. The reason I choose this ice pack is because one of the most interesting aspects of TUDCA is its effects on inflammation, particularly calming inflammation within the artery wall.
We dare.
TUDCA is actually a gut hormone that can be made by your microbiome, and it's also a supplement. But let's get to some data. In animals with heart disease, if you give them TUDCA, it leads to a dramatic reduction in arterial plaque, or protection against arterial plaque. You can see that here. It's not by lowering cholesterol, but by changing the inside of the artery itself. Here, you're looking at fatty deposits in red. When you give the TUDCA, you see the arteries are protected. And again, this isn't a cholesterol problem. Cholesterol isn't the thing causing the plaque deposits per se. Rather, when particles containing cholesterol get inside the artery wall, there are some immune cells that get inflamed and angry, kind of like Bruce Banner turning into tiny little dangerous microhulks in arteries. Now, I'll dispense with further jargon like endoplasmic reticulum stress, but the point is, TUDCA calms inflammation within the artery wall like a biological ice pack, and this helps prevent the formation of these angry immune cells. They're called foam cells, these tiny little hulks. It prevents them from forming in arteries and ultimately driving inflammation and plaque progression. That's one element, one lens on TUDCA, but this is where the TUDCA story actually takes an unexpected turn, because it also interacts with statins. First, recall that TUDCA is a natural gut hormone made by your microbiome. Now here's the thing, statins have been shown to reduce levels of a cousin compound called UDCA. And if UDCA and TUDCA sound similar, it's because they're the same thing, except one has a taurine, the T, attached, which can be removed, so they're kind of interchangeable. Anyway, why does this matter? Because, and are you ready for this? Reducing UDCA levels is one way statins cause insulin resistance, increase blood sugar, and reduce levels of the key metabolism regulating hormone, GLP-1. Yes, that GLP-1, the one associated with most popular weight loss drugs like Ozempic, Wegovy, even retatrutide. But again, why does this really matter? Well, because tens of millions of people are taking statins. They're some of the most profitable drugs of all time, and they cause metabolic dysfunction in part by reducing levels of UDCA. And this isn't me blowing smoke. This has been shown in a human study published in a highly respected scientific journal, Cell Metabolism. Honestly, I think it's a shame and a stain on science and medicine that this study hasn't been followed up with a larger confirmatory study. I think that says a lot about our priorities. However, the point and the zinger here is that in addition to lowering inflammation in your arteries, this ice pack, TUDCA, is a supplement that you can buy on Amazon right now, no affiliations here, that could actually reverse many of the harmful effects of statins, which is kind of wild when you think about it. And real quick on dosing, because I'm sure you're wondering, with TUDCA, it's probably wise to start at a low dose, 250 milligrams once daily with food. You can increase by 250 milligrams per week as tolerated up to a max of 1,750 milligrams split into 2 to 3 doses. Anyway, that's the dosing math.
Quick sidebar. You'll notice throughout this video, I don't have any brand or product recommendations because I wanted it to be educationally focused, but I got so many questions about this at the newsletter that I decided to put some more information below and over there so you can check it out if you're looking for particular things to look for in brand suggestions.
But what's next in our box? We have, oh, interesting, a charger. This charger actually represents a category of tools connected to a fascinating marker, heart rate variability. I go a lot deeper into heart rate variability, or HRV, in another video. This one, which you should absolutely check out after you finish up here. I also tell a crazy story about Starbucks.
This coffee almost killed me.
But anyway, heart rate variability refers to the tiny moment-to-moment fluctuations in the timing between your heartbeats. And remarkably, heart rate variability turns out to be a predictor of death and cardiovascular risk. At first, this might sound counterintuitive, but your heart isn't just an isolated pump beating into the void. I'm gonna put this down now. It's deeply connected to the rest of your biology, especially your nervous system, which is constantly influencing how your heart functions, adapts, recovers, and ultimately thrives or fails. Heart rate variability, HRV, is essentially a signature of how healthy and resilient that connection between your nervous system and your heart is. And generally speaking, low heart rate variability is bad, predicts an increased risk of heart attack and death, while high heart rate variability tends to reflect better cardiovascular resilience. And importantly, HRV is modifiable. You can increase it, you can improve it, and here are two high-yield ways to do so. The first is exercise, in particular zone 2 cardio. That's exercise performed at about 60 to 70% of your maximal heart rate, or practically speaking, you can usually hold a conversation. Think moderate cycling, or light jogging, or walking around with a weighted vest on a shallow incline while watching this video on your phone. Not to give you any ideas or anything. Anyway, this type of training consistently increases heart rate variability, which I would consider good. In addition to exercise, omega-3s can improve heart rate variability. Omega-3 fatty acids, either supplemented or consumed through fatty fish, like my favorite, sardines. They literally change how your cells behave, both your brain cells and your heart cells. They do so by integrating into cell membranes and changing membrane fluidity. I think about it like the omega-3s are sending your cell membranes to yoga class to get more flexible, and this changes cardiac and neuronal function. Additionally, omega-3s can reduce inflammation, which can otherwise suppress HRV. And omega-3s accumulate in the brain, in particular in the brain stem, and in that way, they can improve the function of your vagus nerve, which literally is the cord connecting your brain to your heart. If you'll indulge me in a little intellectual side quest, there's a really interesting connection between omega-3s and statins, most applicable for half of you. Do you know which half? Women. Something most doctors don't know, and I'm surprised isn't taught in medical school, is that statins, which again are prescribed to tens of millions of people, have the highest probability of hurting women more than men, causing muscle issues, increasing blood sugar, and the reason why is alarming and has to do with omega-3s. You see, women have 2 X chromosomes, and men have 1, and that dinky little Y. And that difference means women have higher dosages of certain genes, those on the X chromosome. And yes, for those of you who know about X inactivation, you're really smart, but not all genes are fully suppressed in the second X chromosome, so my point stands. Anyway, one gene women have a higher dose of is involved in omega-3 synthesis, including the generation of the long-chain omega-3, which you get from fish, DHA. Now here's the point. Research shows that women who have increased blood sugar on statins also tend to have more suppressed omega-3, more suppressed DHA because of this sex chromosome statin interaction. So the solution is obvious, right? Just give back some fish oil, give back some DHA, or go on a sardine diet if you want.
Welcome to the Sardine Challenge. So the only thing on the menu for the next 3 days is sardines.
So for those of you who are women taking statins or know women taking statins, I think fish oil or something to boost omega-3 levels is an incredibly wise choice, both for heart rate variability and to offset some of the negative effects of statins on things like blood sugar. Now, next in our bag, we have a straw. What do straws do? They suck up things. And that's a pretty good metaphor for our next compound, berberine. This is a bendy straw. Anyway, you'll see why in a moment, but just hang in there. Berberine is fascinating because it can improve blood sugar control, and blood sugar regulation is really important for cardiovascular health, but berberine can also lower LDL cholesterol and ApoB, kind of like a statin, but also totally not like a statin. I find the mechanism by which berberine lowers LDL and ApoB incredibly interesting, because it's unlike any cholesterol-lowering drug I can think of. Here's the basic idea. LDL particles circulate throughout your bloodstream, carrying cholesterol. One way your body clears them is through LDL receptors. I'm gonna put this down now, I'm having too much fun. One way your body clears them is through LDL receptors that stick out on your liver. They grab the particles and they suck them out of circulation, hence the sucking. Now these LDL receptors, these sucky straws, are constantly being built up and broken down. They turn over. And here's the key. To build up more LDL receptors, more straws for sucking LDL particles, the cell needs a blueprint, an mRNA transcript that is basically the blueprint for the cellular machinery to build the LDL receptors. So think of it as an assembly line. And the longer the blueprint survives, the longer the factory workers can work to make more receptors. What berberine appears to do is it protects that blueprint from making the LDL receptor. Specifically, it stabilizes the LDL receptor mRNA transcript, and that dramatically extends its lifespan by roughly threefold. And this means liver cells can produce more LDL receptors because the workers have more time with the LDL receptor blueprint, allowing them to make more LDL particle-sucking straws containing cholesterol right out of the blood. Mechanistically, this is really elegant, and importantly, it's very different from statins or other drugs. Statins, for example, work largely by creating a state of relative cholesterol starvation inside the liver cell through inhibiting cholesterol synthesis, and this causes a compensatory response. But berberine doesn't work that way. And unlike statins, berberine tends to improve, not worsen, metabolic markers like insulin sensitivity and blood sugar. And that combination makes berberine a really remarkably interesting tool. And if you want human data, controlled trials show that berberine can lower LDL cholesterol by up to 25%, in some cases approaching or even exceeding certain pharmaceutical therapies. But that brings us to our final object in the bag. Can you guess what it is? Pause the video, guess? Not really. Duct tape. Now this one works by a little bit of analogy through inversion, because the tool we're going to talk about, the humble and misunderstood vitamin C, actually works against another sticky tape-like molecule that has become increasingly important and feared in cardiology, Lp(a). Maybe you've heard of it. Lp(a) is essentially an LDL-like particle floating around in your bloodstream, except it carries an additional extra sticky tail called apolipoprotein a. And that structure appears to make it problematic, let's say. High Lp(a) levels are now recognized as an independent genetic risk factor for cardiovascular disease, heart attack, and stroke. And I have high Lp(a), so it's a personal interest. It can increase risk of heart attack by as much as 230%. But where does vitamin C enter the picture? Well, there's a fascinating hypothesis championed most famously by two-time Nobel laureate Linus Pauling. It proposes that vitamin C may help counteract or neutralize some of the damaging effects of Lp(a). In fact, it's thought that Lp(a) might function as a kind of evolutionary substitute for vitamin C. Interestingly, animals that can make their own vitamin C don't produce Lp(a), and that's most mammals. But those animals that can't make vitamin C, like humans and guinea pigs, we make Lp(a). To keep it really simple, when vitamin C is insufficient, Lp(a) might help stabilize damaged blood vessels, essentially acting like a temporary biological patch, like duct tape. It keeps you from dying in the moment, bleeding out evolutionarily, but it might also slowly kill you as plaque builds up in your arteries from the stickiness. And as a case in point, when guinea pigs are deprived of vitamin C, again, guinea pigs make Lp(a), they develop rapid atherosclerosis, heart disease, characterized by plaques that are filled with Lp(a). Conversely, when guinea pigs are given vitamin C, very little Lp(a) deposits in the arteries. It's a compelling pattern. Now, such experiments are hard to conduct in living humans, but if I were to make it really simple, vitamin C can make Lp(a) less sticky. But there's more too. Vitamin C reduces oxidative stress, acting as an antioxidant, and it improves nitric oxide in blood flow, which is actually another way Lp(a) negatively impacts cardiovascular health. So it's a 1-2 punch against Lp(a). All this means vitamin C can improve blood flow and allow for a protected, healthier blood vessel lining. But dosing is important. 500 milligrams twice daily is a good place to start. You can increase to 1,000 milligrams twice daily if you want. Splitting the dose just helps improve gastrointestinal tolerance and absorption a little bit. And here's another quick sidebar. That 2,000 milligram, 2 gram total dose might be doing something else entirely. Really amazing research published earlier this year, which I covered in another video, vitamin C. Vitamin C, yes, but don't be fooled by the apparent mundaneness of this molecule. Suggests that vitamin C may help improve overall health span. The mechanism is truly fascinating. You see, as we age, our cells begin hoarding iron, which activates a pathway in cells called ferroaging, ferro meaning iron. Now the solution doesn't appear to be eat less iron. It's more of an iron sequestration problem, where cells essentially become little tiny iron vaults. And that buildup flips an aging catalyst switch in cells, which accelerates biological aging. So researchers set out to find something that would turn off this aging catalyst switch, and they stumbled upon vitamin C, which can bind to it and turn the switch off in a way that was never previously understood until this year. The researchers even ran long-term experiments in monkeys and found that high-dose vitamin C, the human equivalent of that 2 grams per day dose, could slow brain shrinkage. So vitamin C might not just support heart health, but potentially brain health and aging and overall health span and longevity too. And also, if you math it out, that daily dose of 2 grams costs about 6 cents per day. Talk about value. It's kind of wild. Now, I hope you found this video valuable. And if you did, my last ask to you is to please consider subscribing and leaving a like. It genuinely helps support the work we do here on this channel and elsewhere. Stay curious. Thanks for learning with me.